Hello everyone, hello Mathieu. Mathieu, can you hear me?
Yes, of course, Laura. Good afternoon. Laura, should we start already?
Yes, please.
All right, so let's go ahead.
Ready for people connect.
Welcome to this Danfoss Climate Solution webinar titled Upgrade Your Commercial Cold Chiller or Heat Pump to Next Generation. My name is Mathieu Stoll. I'm a Global Marketing Director at Danfoss Climate Solutions, and I'm in charge of the strategy and component portfolio for cold chillers and heat pumps. I've been with Danfoss 8 years now. I started as a variable speed application specialist, and after 2 years, I moved to marketing. Prior that, I've been working at Train in Europe for 7 years in the R&D department. So let's get to it.
Great, and because you're already doing everything in the introduction, I just have the practicalities, right? It's important for everyone to know that your microphone is muted by default. And of course, there is a record of this webinar so that everyone can access also after on demand. So that's the main thing you need to know now. And next thing is also that, of course, you're very welcome to ask your question in the chat or in the question box. So please see on the right side of the screen and you will see the chat and the question box. And we are here to reply to you while Mathieu is talking, or we can keep some questions at the end of this presentation. Thank you. Enjoy the show.
All right, back to me then. So let's start with the trends affecting cold chillers and heat pump, and that are in turn driving Danfoss component roadmaps. The main trend today by far is climate change and in turn decarbonization. It takes several subcategories, let's say. First, we have direct CO2 emissions. This is basically what happens when refrigerant is released into the atmosphere. This is handled by the F-gas in Europe, and it calls for us to qualify first medium GWP solutions. We're going to talk about R32, R45 today, but also longer term solutions, so very low GWP solutions. It is also about lowering system charge. So for us, offering the exchanger technologies that will allow to minimize this refrigerant system charge, both with microplate heat exchanger for water exchangers and microchannel heat exchanger for the air exchanger. Then we've got the indirect CO2 emissions. This is basically the CO2 that is released into the atmosphere while producing the electricity to run our systems. In other words, this is about the seasonal efficiency of those systems, and this is regulated by the eco-design in Europe. So how do we contribute, how do we support you when it comes to seasonal efficiency? So first, this is about system modulation. So when it comes to fixed speed scroll, we obviously offer a full range of manifold compressor. Can be tandem and even tandem, even hybrid tandem trios, if not quadros. But we also have variable speed compressor, which really makes the high tier in terms of modulation. But it is also about being able to modulate fans and pumps, and where Danfoss comes into play is definitely with our inverter offering that can be applied with fans and pumps as an alternative to EC fans, for example. But it's also about the pure or raw efficiency of each components, or at least having efficient components where it matters. So if to talk about our compressors, they are all 100% of our AC compressors are equipped with Danfoss IDV, intermediate discharge valve, which allows to reduce the energy consumption at low lift conditions. So in other words, part load in cooling, a very nice effect on SCR, unfortunately no effect on SCOP. It's also about offering best-in-class exchanger that will allow to reach the best approach temperature. So again, our microplate heat exchanger offering, as well as our micro-channel heat exchangers. But this would never be possible without a proper superheat control in the system. So it is also about having best-in-class electronic expansion device and superheat control algorithm. Then the third thing is the transformation of the heating sector that we call the electrification of heating. This is really boosted by the Green Deal in Europe. And what it really means to us is the need for a compressor that have an operating map that perfectly enable reversible application and preferably without injection. So it's already been the case with R14A. It is the case with the new refrigerant. It's been a bit of a challenge with R32, but we will see in a moment that we were also able to make it. It's also about, in Europe, those high temperature heat pumps that we can find for district heating or industrial heating. And when recovering heat from a wasted heat and using it as a heat source, this type of technology will demonstrate really the highest type of efficiency possible. Another important trend is definitely the digitalization. So what it means to us, it is calling for connected and smart components. This is also something we are working on, but that will not be developed today. And finally, data center need to operate into the best efficient ways possible. This calls for higher water or air temperature depending on the data center architecture. And in turn, that means compressor offering high saturated section temperature. When it comes to scroll, this is really nothing new to us. We have already extended the operating map of all of our compressor since maybe 5 years now. But yeah, the main topic these days is definitely refrigerants. Eco-design days, they are a bit past when it comes to scroll chiller and heat pumps. We are already in the tier 2 now with the 2021, so we are waiting for the new say updates of eco-design. Not sure when that will come yet. So today the main topic is really refrigerants. So you have seen this type of graphical representation before. It's very simple. The y-axis is the GWP of the refrigerants. We simply want to be as low as possible. And the x-axis is the volumetric capacity of the refrigerant, which is most of the time, and there are a few exceptions, but most of the time it is true, completely correlated to density and pressure. Additionally, I have added on top of this graph the main compressor technology that we can find out there and where we traditionally find them with which type of refrigerant density or pressure. So from left to right, we've got those large centrifugal, then our turbocore oil-free compressors, followed by the screw technology, then the reciprocating compressor, and finally the scroll compressor. We could definitely add the small rotary compressor next to the scroll compressor. So on this graph here, you are seeing all the refrigerants that we have in our radar in Danfoss climate. What does that mean in our radar? It definitely doesn't mean that we are going to release optimized compressor for every single of those refrigerants. I mean, in terms of R&D, this would be insane. But those are the refrigerants we follow closely, and you can definitely expect that all of our line components will be released with those refrigerants. Just the compressor, when it comes to compressor, we have to drill down a bit, make a shorter selection. So we are here to talk about scroll chillers and heat pumps. So today, yesterday I should say, the main refrigerants was R14A. So when we look for the replacement of those R14A, so we can start by looking down into this R14A column, and we can find here this box. So here you see 4 refrigerants that we have in our radar as a medium GWP solution to replace R14A. If we continue to look down, unfortunately, we cannot find anything. So as of today, there are no long-term, very low GWP obvious replacement for R14A. So this compels us to look to the left, to lower density refrigerant that may not necessarily be used with scroll compression technology. So what do we find here? Definitely there's propane, and the two pure HFOs, 1234Z, YF, and some of their blends. So when it comes to compressor offering, further reducing this list, we make it here to this next slide, so you can find the various applications that we are targeting in Danfoss climate. Topic of the day is commercial chillers and heat pumps. So let's look at the dark blue box here. So say yesterday the main refrigerant was air forte, where we have placed our bet for the midterm. We have selected two refrigerants. We are going to offer two avenues. One is R454B and the second one is R32. As long-term alternative, we have also identified two refrigerants that may overlap a little, but contrary to R32 and R454B, that should address very specific capacity segments. First, we have 1234Z and his blend R515B for the large commercial segment. So you can see here 150 to maybe 800 kilowatt. While for the residential and light commercial segment, we believe more into propane as of now, despite the A3 category. So today, I'm going to take you through these various avenues, at least avenue 1, 2, and 3. As of today, it is a bit early for me to take you through our propane plans. So let's start with avenue 1, that is R454B. I should maybe rather say this is our multi-refrigerant avenue. This is not only about R454B, this is also about R410A and R452B. These two refrigerant 454 and 452, they are the closest drop-in to R410A, and as such, they do not require any specific optimization. So what sense would it make to develop specific product ranges for those refrigerants? It makes much more sense to take our best-in-class R410A products and qualify them with these additional refrigerants. If they are optimized with R410A, they are also optimized with those refrigerants. Basically what it means, if you take any of the components that you see here, with the same bill of material, you can build, assemble a chiller and decide down at the charging station if it's going to be R410A or R454B design. It can be quite convenient. So I'm going to go through our current offering, and if you see something in the line, it simply means this is a near-term development. You can assume a release within the next 6, maybe tops 18 months from now. So the capacity range this is covering, so for commercial scroll applications, is 50 to 800 kilowatt here. So what does that mean, 800 kilowatt? It means in a conventional design today, 2 trios of 50 ton, and so a 2 circuit unit with 1 trio on each circuit, or maybe with quadros of 40 ton. If we really wanted to push it, we could even go to quadros of 50 ton compressor and reach the megawatt. Let's start with the scroll compressor. So first of fixed speed scrolls, it's called DSH, same as R410A, except that it has been qualified with all of those refrigerants. So this is a traditional lineup with a medium and a large platform. So medium 7.5 to 15 ton in 6 models, and then 20 to 40 ton in 4 models. We have also our 50 ton, not yet released as a multi-refrigerant compressor, but that you can already use as R410A only. Of course, complete manifold is available, all compressor equipped with IDV, and be it 454 or 452, we offer the same operating map as R410A, which is really appreciated when it comes to reversible applications. Now, variable speed scroll called VZH, you likely know it. It's the broadest variable speed scroll range in the market. It's made of three sub ranges. First one 4 to 7 ton in 3 models. Second one is 8.5 to 11 ton in 2 models, and the one that is already released with R454B, the commercial one, from 13 to 26 ton in 3 models. Of course, we offer hybrid tandems to be able to reach higher capacities. All of those models are equipped with IDV and IPM motor, which makes them really truly best-in-class variable speed scrolls in the market. And like the fixed speed, with our 454B or 452, we offer the same NAP as R410A. Then our heat exchangers. I'm going to start with our microplate heat exchangers. So you may know these use the Z-dimple design that enables a better heat transfer for a given surface compared to traditional fishbone designs. Here I would like to highlight 3 new models, the C129 in single, the C129 and C262 in dual. Basically now with these 4 different models, you can cover this entire capacity range. Then it's just about a number of plates. And with these 4 models, we can offer you really best-in-class performance. And this is about an evaporating temperature higher than 4 degrees. We are targeting below 3 Ks of approach here. And they are definitely available as evaporator and condenser for water-to-water application. Now, microchannel heat exchanger. We have had a tube design optimized for those high-density refrigerant for quite a long time. So it's a fully customizable product when it comes to type of tubes, fins, and manifold. We offer them either as slabs or formed. So we may find some formed with a band on maybe light commercial application. The slabs, we traditionally find them on these V designs for the larger commercial applications. We offer these products with several types of aluminum alloys and various coatings to meet your requirements. And this really depends the type of ambient condition that the product will meet in the field, and we have solutions for aggressive environments. Then our line components and controls. Let's start with the electronic expansion valve. So we released this range quite some years ago already, our best-in-class ETS Colibri expansion valve. From ETS 12 to ETS 100, basically with 4 to 5, you don't necessarily need the 5 here, but 4 to 5 models, you can cover the full range above. It is a low weight inline, which is quite different from traditional EXV design, compact and hermetic design. And this goes together with the EKE series. We have our EKE, which is the superheat controller. We are also about to release EKF. EKF is a much more competitive and simpler product than EKE. It's actually a simple valve driver. What it means is then the superheat control algorithm needs to be implemented into the main controller of the system. We also recently released the EKE 2U, which is a backup power module. What it means is in case of power outage, this power module will be able to close the electronic expansion valve fully, ensuring total reliability for your system, preventing basically refrigerant migration to the compressor during the off period. Then we've got our system controller called MCX. We recently released 2 new models called MCX 15 and 20B2, and they offer better performance, connectivity, and security compared to the previous generation. They also integrate some additional algorithm, and I will just name one here, which is the variable speed scroll operating map control. When it comes to sensor, of course, we have a well-known and full range of pressure and temperature sensors. I'll simply highlight our new P110 and EDX communication interface here, and that allows to change the settings, run diagnoses, download and upload data directly between the sensor and your smartphone. And next to that, Danfoss is well known for a full offering of line components and four-way valve, ball valve, check valve, solenoid valve, pressure switches, filter dryers, side glasses. I could probably go on, I'm surely forgetting something. but it's all there. Just know all of these components have been qualified for this new refrigerant. So what it means is, like, with such a broad lineup, we could cover, depending on the application, air to water, 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 but let's say 60 to 75% of the value of your system. So if you want to consider Danfoss as your one-stop supplier, definitely makes sense, and you're welcome to do so. Let's move to the other avenue that we are offering. This one is called then the R32 avenue. So why R32? R32 is also a great refrigerant. It is very affordable. It is widely available. It's already a success in the residential sector, and it has very nice properties. Provided you're able to deal with the difficulty that the refrigerant brings. First thing, R32 delivers an extra 10% capacity for the same displacement, which is very nice if you can make use of it on your compressors. And you can see the consequence of that here is that the capacity range that we're targeting has changed. It was 50 to 800 kilowatt before. With R32, we can target up to 900 kilowatt systems in conventional designs. So what I'm saying here, 2 trios of 55 tons, so the 10% extra made the 50 become a 55, or quadros of 44 ton, the 40 became a 44 ton. And if, again, we really want to push it with 2 quadros of 55 ton, we could even reach 1.15 megawatt systems. So for the sake of time here, I'm simply going to highlight those components that required to be optimized for R32 in order to enjoy the very nice properties of this refrigerant. So let's start again with the compressors. So here we have released a new range of fixed speed scroll. It is called DSF. It's basically the same type of lineup as R14A, but due to the 10% extra capacity, we have had here and there to create additional models to cover at least the same range from the low end. But again, a medium and a large platform, the 50 or 55 ton is not yet released. So there were two main difficulties, say, with R32. The first one is the lower mass flow of the refrigerant. R32 has a significantly lower density than R410A or R454, but it's also the significantly higher discharge gas temperature that, if dropped in just like that in an R410A design, would limit the operating map drastically and would not make it suitable at all for reversible application. So thanks to very good engineering work, design changes, and optimization, we are able to offer, without any type of injection, a very decent operating map suitable for reversible application. It is not quite the R410A map, but it is suitable. It is at least better than the old R410A operating map that we used to find in the past. It's just not as good as our DSH R410A operating map. But for those who really want to use the same map as R14A, just know that we have also developed on the side a discharge gas temperature control solution to enable the exact same map as R14A. Like the fixed speed, we are going to release a new dedicated range of variable speed scroll here called VZF. So this one is a bit further down the road. This is why I'm not going to say much here, and that there's basically no information. But rest assured, it is coming. Heat exchangers. First, microplate heat exchangers. So here we have really optimized the product and released the specific range for R32. You can see next to the model numbers, the 4 frames, C62, C129, for example, there is this -F that marks the specific range to R32. So I said it before, R32 has a density that is significantly different. So in order to enjoy the nice performance of the refrigerant, the distributor of those products had to be optimized and then led to a specific range. When it comes to microchannel, there is no difference here. The same high density tube optimization is also fully optimized with R32. This is just about making the right selection, properly sizing the exchanger to match R32 characteristics. Likewise, all the line components and controls, they are not specific to R32. They are the same components as we just saw before. But you should, if you want to make the best out of R32, again, you should reselect properly all of the components for a given capacity. If you remember before, I was showing, let's just take ETS Colibri as an example. Before, to cover the full range, the ETS 100 was needed. Now, with the ETS 50, you can cover the maximum capacity. And this will be like that for most of the components. They will be either the same size or one size smaller. Now let's move to the third avenue, which is 1234Z, but not only 1234Z. It's actually a kind of multi-refrigerant avenue again. All of the products will be qualified for 1234Z and 515B. So why those two refrigerants? Let's start with 1234Z. So yeah, first, it is a long-term solution. It has an extremely low GWP, and is not even controlled then by the F-gas. It is very efficient refrigerant, at least significantly more efficient than YF, and it is also fairly available. If we compare to YF, no questions. It is really, really affordable. This is also a refrigerant that is already widely adopted in the market, at least in Europe. We can see it is a clear winner in the 134A transition. We can find it on all the new turbo core or screw products. This is also a refrigerant that we know very well. We have a very broad, large commercial chiller strategy in Danfoss Climate on this refrigerant. We pioneered with this refrigerant with turbo core in 2013. And just last year, we pioneered with 515B with turbo core as well. Why R515B? R515B is basically a Z alternative. It's 92% 1234Z and 8% something else, just to make it A1. So with those multi-refrigerant components, you then have access to either super low GWP, pure refrigerant, but A2L option, or slightly higher GWP. The GWP of 515B is just below 300. But it is A1, which can be very convenient, especially for indoor applications such as water-to-water systems. As I said before, this refrigerant, we have selected it for large commercial systems. So you can see that the capacity range has changed. It is no longer 50 to 800 kilowatt. Here we start at 100 up to 650 kilowatt. So 650 kilowatt is the very reasonable 2 trios of 40 ton. And the 100 kilowatt basically means a water-to-water application, single circuit with a simple tandem of 20 ton compressor. Like R32, I'm simply going to focus on the product that require an optimization. So first, the scroll compressor. And this is basically for probably many of you, the main surprise of this presentation. I doubt many people expected to hear about 1234Z scroll short term, but here they are. We are going to develop 2 different ranges. The first ranges will address the traditional commercial applications. This one will release in the course of next year. And I will speak briefly about the second range later. So to cover this large commercial application, we're going to start first with the traditional large scroll compressor range, so 20 to 40 ton, same as usual, 4 models, 20, 25, 30, and 40 ton. Of course, we will offer a complete manifold lineup. This product is equipped with the second generation of IDV, which was basically non-negotiable with this product, and it's very high volume flow. But to give you some inputs here, if I were to compare this IDV Gen 2 design on an R14A compressor to the first generation of IDV, depending on the application, this product would deliver an extra 3 to 7-8% SER. Let me give you more details. Like on a traditional air to water application working at 12.7 water regime, this IDV will deliver maybe 3 to 4% additional SER. On a water-to-water application or on a rooftop application, which is a bit lower pressure ratio or lower lift overall, it will deliver, say, 5 to maybe 6% additional SER. And now on a maybe data center or floor cooling application and with a water regime of 2318, something like that, we could count on a 7 to 8% additional performance. So it's just a matter of time before you find this IDV also on a higher density products. So probably the main thing you're wondering about is, my God, how big is this coil getting? Like, the main thing about 1234Z, to reach the same capacity as R410A, you need 3 times the swept volume, which is huge. By comparison, like R22 is only, or propane is only 1.6 times the swept volume of R410A. Here it is 3 times the swept volume. So one would expect probably a super tall compressor or very wide, or maybe something that looks like a mushroom for the scroll set, I don't know. But let me give you here a quick sneak peek of the results of our engineering work. So here we are comparing 40-ton R410A products, the DSH, to the 40-ton DSG product that is already available as sample, by the way, if you're interested. So if you compare the total height, we can see that there is only an extra 6.7 centimeters. Let me simply tell you that if this was purely the height increase due to the scroll set, it would be significantly higher than that. And what I mean by this is our engineers found ways to reduce the height contribution of many other classic and typical components of scroll compressors. You will understand I cannot go into more specifics. Then if we look at the diameter, the top diameter where the scroll set is located is only increased by 1.3 centimeters. And the main diameter of the product doesn't show any change. Okay, this is driven by the motor, so this is in a way expected. Really a new and innovative product. So to support this strategy for scrolls, when it comes to heat exchanger, we would like to be able to offer something else than the typical shell and tube heat exchangers. If you look at screw or turbocore or screw products today, they use shell and tubes, but fluided shell and tube in order to have decent enough performance. As you may know, scroll compressor, they do not really work well in the fluided conditions, so some superheat is needed. So the basic traditional shell and tube simply wouldn't cut it. So what we are also investigating is a new optimization specific for 1234DE that will result in a new and specific microplate heat exchanger range. This is a bit further down the line, so please understand if I'm not saying more on this as of now, but we want to support the whole strategy with all the overall strategy with all the type of components we offer in Danfoss Climate. When it comes to microchannel heat exchanger, here, no real issue. We have had for a long time tube design optimized for 1348. That has been used also with 1234Z. It's widely used in Europe. So this same microchannel could be used also with these scrolls. But do know this, we are just releasing right now a third tube optimization, this one specific, really targeting 1234Z for turbocore and the screw Z applications. But this design will definitely also be available with 1234Z scrolls. I encourage you to look into this, if not with scrolls, also with turbocore or screw applications. Then our line components and controls. Here, there isn't much to say. They are the same components as before. They are already widely used on on 1234Z, screw, and turbo core products. You simply have to select the right size for the refrigerant.
Super.
All right, and this takes me to this last slide here. So now you may wonder, like, this is very nice, Danfoss. Like, we see that you are able to support you into these various avenues, but I'm a bit lost now. What refrigerant do I select? Do you have any recommendation? So the first thing I will say here is there are internal dynamics to each OEM that will drive the final decision. So without considering this, if you are asking us for general guidelines, this is the type of answer we would provide. So there are several types of criteria we can look at to evaluate and compare those refrigerants. The first one, obviously, the GWP level of the refrigerant. Second, seasonal efficiency of the system. The safety, if it is flammable or not, particularly relevant to water systems. The applied cost, very important one for you, sure. So how this was made. So we have evaluated the applied cost at ISO capacity for all the refrigerant, and this for a given design. And this given design yields a specific seasonal efficiency, the same that was used in the seasonal efficiency estimation, the second bullet. But of course, there is a very strong dependency with the refrigerant prices. So what it means is this evaluation of applied cost is very time and space dependent. So here for this exercise, we have taken the consideration of today, the prices at which those refrigerants are available today, and in Europe. If you're wondering about transition outside Europe, you can take a quick look at the arrows on the right, and we have mapped what we believe will be the various transition in the where they are, and what will be the transitions in the various regions. So very important to say that this is the picture of today in Europe. What can we expect down the line? If we look at the HFC phase down, even though it doesn't really reflect on the price of the refrigerants today. If you remember the R410A price of 2017 and the R410A price that you can find today, doesn't seem to make sense. But okay, eventually down the road, this should make sense. So if any refrigerant price is going to go up, it will be those of high GWP. So what we can expect is that the R32 and R454B further down the road will see their price increase while the prices of the E should remain free of this quota mechanism. So this will definitely move in the right direction for these 1234Z solutions. Next criteria is the footprint. So it's not so much about the height or the width of the system. These large commercial systems, they all fit into those large containers. So this is pretty much standard. So this is really about the length of the system. Laure, Julie, my computer just says I'm going to restart in 1 minute. There is nothing I can do. So just know that. So I'll be very quick. I have 1 minute left, so I will let you look at the spider graph in the middle. This is the result of all this evaluation. And as a conclusion, I will just say this. We have these 3 avenues. So first, we have the multi-refrigerant avenue. This is the easiest transition from an existing and compliant R410A design with a potentially longer lasting options for R454B. You must have noticed R454B has a GWP significantly lower than R452 or R32. Second avenue, R32, this is to transition to the best efficiency and applied cost, but this requires a complete redesign. And finally, the 1234Z and 515B avenue, this is the innovation.
Okay, so we're sorry, but there is this break to conclude. We are far beyond the timing. So all questions will be replied directly by email after the webinar. And we are sorry for this sudden stop. But if you want to ask any question to the team, you're welcome to reach out to us directly at the booth. and you can contact Paolo De Siati or Giovanni Aguito or any of the team who is available there. Otherwise, it's available on demand, so you're welcome to reach out to us and to see it in YouTube. Thank you very much, everyone, and thank you for joining us. And just join also other webinars tomorrow about oil-free chillers, about close controls, and we will be happy to welcome you there. Thank you so much.